computer. There we go. Recording in progress. Okay, guys, we're going to do part two of day 5. Um, Recap time, just to make sure we know where we're at. We were doing plots all last week. We were working primarily with the cigarette stock Watson data set. Um, and then for some more advanced histograms and density plots, we were looking at the credit card data set. Both of those were coming out of AER. And that AER has like just a massive library of data, of I guess kind of canonical data sets that have been published, and we can kind of do some interesting things there. Yesterday we switched gears a little bit with this NYC. Oh, I'm not even sharing my screen. You can't see that with my NYC flights data set. Let's go and share that up. Yeah, we were working with NYC Flights 13. If we remember, NYC Flights 13 is coming from the US government. This is official data out of the Bureau of Transportation Statistics. These are all flights arriving and departing from the 3 major New York airports, so JFK, LaGuardia, and Newark. And this is for 2013. So if we go up to our environment here, we can see that this is 336,776 observations across 19 variables. If I just do like a little inspection here, we can just go ahead and click this. Is a nice way to kind of get a good look at it, right? I got year, month, day, but I also have departure time, departure delays, arrival delays. I've got the carrier, I've got the flight tail numbers, origin and destination, airport codes, how long they were in the air, distance in miles. And yeah, we've got quite a bit of a wealth of information. What else is in this flights or a part of this flights data set? So if I just go ahead and look at flights, does flights give me everything in here? Let's look. Flights, I got some other stuff in here. Yada, yada, yada. Joint flights data to weather data. So we can got quite a bit. If I do the double question mark, NYC flights 13, should pull up the vignette on NYC flights. That didn't do it. Let me go over to my packages and we scroll down here. NYC flights 13. Here we go. Flights is just one data set of 5. So I've got airlines, airports, planes, and weather. So presumably, you may think, well, why do I have 5 other things? Well, if I go into my flights data set here and I take a look, I've got airport codes, I've got tail numbers, and it looks like I've got hourly weather data as well. And so it looks like I might be able to merge some of these other fields in with these other data sets to provide a fairly rich data set around, a fairly rich data set around, or I'm sorry, not data set, but a fairly rich picture around what's going on with these arrivals and departures out of these airports. So kind of a couple of the things that we discussed yesterday, the 2 big ones were the fact that there are NAs in our data set, right? So we talked about NAs a little bit in terms of sort of what they are and what they do. NAs are a bit of a blessing and a curse. They hint at the structure of our data and what's going on. They hint at how the data is collected and kind of what it means. But they also provide challenges in terms of, well, if I have an NA that's anywhere in data that I'm trying to perform a calculation on, like a summarized calculation particularly, it's going to cause me some issues. And so they're nice. They're great in that they kind of let us know that there's something going on in the data, but they also require just a little bit of extra care and handling. So that way we understand our data. And when we went through it yesterday, what we saw was that we had some NAs in our departure data. So these would be flights that were presumably canceled. And so they were showing up as NAs. I believe we had roughly about 8,000 of them, give or take. And so, as a first step in our data, one thing that we did was, here we go. We went ahead and filtered those out so that way they didn't contaminate our data set. And then, kind of a little bit more generally, we had to think about what we wanted to, I guess, sort of define as a delay, right? So departure delay is just a simple calculation, right? All it does is it says, okay, when was the plane scheduled to depart, and when was the plane scheduled to arrive? When did it actually depart or arrive? What's the difference between those two numbers? It can be a positive or negative. Um, does that mean that the plane was late if there's a positive number in there? What if it's a positive one? Does that really mean that it departed late? Right? Probably not. I mean, is it likely that an airplane is going to take off exactly at 6:55 in the morning? Probably not, right? And so, not only do we have to treat these NAs, but then we have to think about, okay, well, if I say that something arrives early or late, yeah, how do I define early or late, right? And so even before we kind of get into the bulk of our analysis, we as the analyst have to now make decisions around, all right, how do I want to define what these things mean, right? So, you know, it's kind of common parlance, right? Like you go into the airport, I'm running late, or my flight's going to take off, we arrived early, right? And we kind of have an intuitive understanding of what those things mean, right? But we're now in the realm of data. We're now in the realm of computers, and anything that isn't the exact value is going to be either early or late. And that's not necessarily the case, right? I don't think that we would ever say, "Oh, the plane arrived 3 minutes early." I wouldn't say that, right? I mean, I've got an 8-year-old who's at a very literal phase of her life. And so she might say, well, no, daddy, we arrived 3 minutes early. And yes, technically you're correct. Okay, I got you. But more generally though, like we would not, we would say this flight arrived on time, right? If you arrived, let's say 15 minutes early, 20 minutes early, 30 minutes early, okay, that's an early arrival. Or if you departed 15 or 30 minutes late, those would be perhaps, right, a late departure. And so we want to kind of have some sort of a definition around, what these values actually mean. And I think I asked you guys something about that in the homeworks as well. And so that's kind of where we are all caught up. Let's see, where do I want to get you guys going here? A lot of the work that we were doing was around these filters. Um, yeah, we can do around these filters. There are two ways, if you recall, that we were treating these filters, particularly around these NAs, right? One is that we can explicitly um, declare, right, what this NA means, right? So again, just take out this is, take it out of the data completely. But there may be cases where I don't want to do that. And if you show you in here, I'm just going to do mean. There is an option flag in here. It says NA.RM equals false. What this means is that RM means remove. So NA.RM equals false means that if there are any NAs in the data, mean is just going to treat them like any other number, and it's going to try to do a calculation on it, which means if there is an NA, it's going to throw you an error. If I had NA.RM equals true, automatically in the calculation, it would go ahead and chuck it out. Now, why might that be some sort of a problem? Let's go ahead and just kind of show you a little more explicitly here. Let me go up. I think we did a little bit with this yesterday. Let me see what's a good place to start this. Here we go. I'm going to do flights. If I can spell correctly. I'm going to go and pipe this in. Oh, and I'm just going to do a quick summarize. Mean, and I'm going to just say flights I'm just going to say departure delay, right? Let's do group by. I'm going to say origin. Do origin. Group by was another one, right? So group by allows us to group our data, right, according to a common factor. So in my origin, I've got three particular values in here: LaGuardia, Newark, and JFK. And so rather than giving me an average for everything, I want an average just for each originating airport window. And then I'm going to do mean departure delay. I just sign that. Average delay equals mean. Okay, if I run this, which should allow me to do something, right? And I want to go ahead and view it. View. So if I do that, I get a bunch of NAs, right? This is my original data set, right? We kind of saw that. Now, what if I filter? Is that NA, departure delay, right? Oh, hey, hey. Let's get back here. Come on. Now let's say I want to add one more. Say flights. All right, I want the number of flights and the average departure delay. Right. So let me go ahead and run this one more time. I'm going to kill. So number of flights, right? So I've got roughly 120,000, 111,000, and 144, or I'm sorry, 104,000. If I do this filter, right, I should get something a little bit different. If I do that, yep. So right off the bat, EWR, which is Newark, it was 120,000. Now it's 117,000, right? And now I actually have values for the average departure delay. Right? Why is that? We've filtered out those NA. So we've done, not, this little exclamation point is not is.na. So checking to see if it's an NA. If it's an NA, I want to flip it and I want to keep it. So I only want those that are not NAs. The other way we can do that is with the NA to RM. RM equals true. So this should give me a similar answer, right, as we got here. So I have a 15.11 for my, or 15.11 minutes for my average departure delay out of Newark on 117,000 flights. And by doing this, right, I'm not filtering everything out. So this number should stay the same. This number should go back up to the original tally. So I do that. Bingo bango. We're back up to 120,000 flights. The average didn't change, but the number of flights did, right? So do you see the difference? Like I get the same number, right? I get my average departure delay doesn't change, right? Because I'm getting rid of these NAs from my data set. What does change is what data is now kept for the rest of my calculations, right? So by doing this filter, I'm automatically filtering everything out that's an NA, right? That's now chucked. We've gotten rid of that, right? By doing the NA to RM equals true, I'm just ignoring those NAs just for this one calculation. The data that's in those rows is still available to R for use by me for other things, right? So for instance, if the departure delay is there, not because that it never took off, but let's say that it's just an error, right? Let's say these are manually tabulated data fields, and whoever the air traffic controller was at the time just forgot to enter the data right into the system. do I want to now exclude that row forever, right? For the rest of my analysis? Maybe not. Maybe there's valuable data in there that I want to use later on in my calculation. But let's say I'm trying to generate a summary of the quality of flights that are coming, that are leaving these airports. I may want to have that data still available to me later on, in my calculations or as part of my summary. So maybe I don't want to just get rid of that just yet, right? Maybe I just kind of want to get to an average. I want to see what's going on, but there's other data in those rows that might be valuable to me. Does that make sense, guys? All right. One, like I said, like this explicitly filters out that data. This one, what we call implicitly filters out that data, right? Implicitly meaning, for the purposes of this calculation, we're just going to ignore those NAs. Here, I'm just chucking them out entirely, right? So whatever was in those 8,000 rows, is now gone. Okay. This is again one of those kind of touch points around, uh, just the decisions that you would have to make. Is there one way that's better than the other? No, there isn't. Um, you just got to be mindful of which one you're using and sort of choose them accordingly. Uh, Kind of also as a slight kind of detour, you'll see how this one is true. It's capitalized, right? There's no quotes around it. And in RStudio, it automatically changes the color here to like a bluish, purplish color, right? That's because it's a reserved word, right? So if I did, let's say, filter, another way I could write this is filter depth delay doesn't equal NA, right? Is another way these two statements are equivalent. Right? And you see here, NA, right, also shows up as purple, like a purplish blue. That means it's a reserved word. So let's see, NA, true, false. I think and nope. Nan, not a number. Um, these are what we call reserved words. So if you are trying to create variables in your data set and um, you try to do one of these for reserved words, R is going to throw you an error. But what you can do is some kind of clever kind of filtering operations on it. Does that make sense? That cool? Cool. All right. Awesome. Awesome. Let me go through here. A bit more generally with our filters. Filters are really just true false statements, right? When you're doing a filtering, you should be thinking about your data in terms of true false, right? So what do I mean by that? Let's say that I want to, let's go and start over here. Okay, let's say that I want to, we were trying to create a data set called winter flights. Winter flights included flights that occurred in December, January, and February. And so what I wanted is something that returned a true false, that if month was one of these three, right, it would return a true. Otherwise, it would return a false. And that is in fact what is happening here, right? So month in, right? So what the in operator does is it checks to see if the value in month is in one of these three numbers. If it's true, it's true. If it's false, it's false. So let me go ahead and show you this a bit more generally. I'm going to do months equals, this is going to be a fun one. Let's say you want to do a sequence of numbers, right? Let's say you want to do 1 to 12. I can do 1 colon 12. And I do months. 1 to 12. All right. It's a nice little hack, so you don't have to keep typing things out. Let's go ahead and let's start underneath here. The mechanics of filtering. And this is I don't know if you ever really get into this or not. And he's like, this is how I think about like filtering. So in my head, if I say like, okay, I need to select a sample, right? Like I've got this raw data. Um, how do I get to my sample? What is it that I'm trying to observe? This is the picture that I'm creating in my mind. So if I just do say months 1 to 12, right? So I gotta create that. And this does, so that's my output, right? And let's say that I want months equals, let's say, give me a number between 1 to 12, just at random, anyone, I don't care.
7.
7. All right, months equals 7. All right, what do I think my output's going to look like if I run this? Just take a guess.
Is it,
Hmm?
is it going to be more to the right?
Well, okay, so if I do months equals 7, uh, well, let's go and run it. Let's go and find out. This is going to be pretty cool. So you kind of got an intuition, right? It's going to give me something, right? So how many numbers are in this variable months?
12.
12, right? So my output's going to be 12. I'm going to have 12 of something, right? Is what I'm going to have. Now I'm doing equals, so I'm comparing months to this number 7. And because equals, um, it's going to return a true false. And what's going to return is 12 true falses, right? So when is it going to be true? When is this statement true?
When it equals to 7?
Yep. Yeah, exactly. When one of the values in months equals 7, right? So let's go and run that. Look at what I got, right? So 1, 2, 3, 4, 5, 6, boom, 7, true. So all these are false except number 7, and then the rest are false, right? 8, 9, 10, 11, 12, right? So these are all false except for this one is true, right? So if I were filtering, right? If I were just doing a filter, like if I just want to know what was happening in the month of July, right? If I go back into my data, let's go get rid of all these are ugly. If I go back into my data, right? Where's my month, right? All of these would be false. All of these would be false, right? This is just throw a bunch of Fs. These are all Fs, right? Until I get to month 7, right? And then it's going to be a bunch of trues. So what is that filter going to return? Filter only returns when the values are true, right? So it ignores all the falses and it only returns the true. And so that's kind of what you should be thinking of, right? So you're taking your variable here that you're trying to filter on, whatever whether it's a month, whether it's a, departure delay or whatever, um, you're only returning those values that are true. And so when you're setting up your filters, right, think of in terms of, okay, what do I want returned? What do I want to be true? If I did less than 7, right, what am I going to return? Which one of these are going to be true and which one's going to be false?
Everything before 7?
Everything before bingo. Okay, that's an important point. That's a bit of a trick question. So I do less than 7, run that. What do I get? Right? Everything before 7, right? Not less than or equal to, but less than, right? So if you're thinking about, what data you want to include, what data do you want to exclude, this is going to return it's going to return those rows where 1 through 6 are in months, and it's going to give me false everywhere else, right? If I did Let's do this for equals less than or equal to, right? And I run this. Oh, I get one more true, right? Why is that? Because I don't want it just less than 7, but I want it less than or equal to 7, right? Does that make sense? It seems pretty so like, this is like what was this? Like you did this is math we did like in elementary school, right? Inequalities, right? Which one's bigger, which one's smaller, which one's bigger or equal to, right? These are, yeah, it seems pretty trivial, but you'd be surprised that are what do you want as part of your sample? What do you want excluded from your sample? And by doing these inequalities, right, they allow us to do some pretty interesting stuff. And then if we have like lastly the months, and if I want to choose some, let's say I want to do see 12, 1, and 2. If I run that, right, what do I get? I get this down here. Right. So months 1 and 2 are true, right? The rest are false. Month 12 is true, right? And that's kind of what the in does. The in says, okay, I don't, I can pick and choose which numbers I want this to be compared to and allow it to return true and false based on those. So when we do our filtering, only those values that show up as true here, right, are going to be returned as our data, right? Everything else is going to be excluded. Make sense? Clear as mud? Cool. These are, doing these filters, working with these inequalities. Yeah, this is the name of the game, right? So, whenever I am in the so in Econ 345 that we teach in the fall, we dedicate. Okay, so we teach this as it's a 3-hour class every Friday. We probably dedicate the better part of a lecture and a half just to this single subject. Because as you start getting into your data, as you start getting into, really some of the projects that you'd be using R in, how you define your data becomes very, very important. As equally important, can you reconstruct your original source data from the code that you are running, right? So not only are you showing, okay, what is my sample, but also what data did I exclude from my sample and what does that data look? What were the choices I made, right? So maybe it's because the data is corrupt and it's got a bunch of NAs in it. It's got a bunch of erroneous information. Maybe the values are just wrong, right? Like, so let's say you have classroom information about student heights by grade, and you've got a bunch of negative values in there. Can you be a negative height tall? No, that's absurd, right? That's a data error. Like I want to exclude those data errors from my sample. And, and as I'm doing my write-up, I may say, okay, I have 100,000 observations. 10,000 of those we excluded from our analysis for these reasons. One, 5,000 of them were incorrect entries. They were showing as negatives. Another 5,000 were NAs, so they weren't recorded. That left us with 90,000 in total for our sample, and then you can kind of just move on. What really kind of the aim with all this is to, again, build that credibility with your audience, right? Like, are the results that you're telling me true? Did you do the work? Did you do the right work? Did you do the right work on the right set? Is this even the right set of data to be looking at? Your audience doesn't have the data in front of them, right? They just don't. They may be familiar with the data. And if you're lucky, they are. And so if you do anything that isn't kosher, they can call you out on that. But more often than not, they don't have the data, and they may only have just a cursory understanding of what's inside of it. only you know the complete picture of what this data looks like. You know how ugly it is. You understand how it was collected. You know all of the pitfalls. You know all the questions you can ask of the data. You know all the questions you're not allowed to ask of the data. These are things that you know, and you want to be able to communicate that with your audience in the best way possible to be able to build that trust and not have the discussion hung up around really what is sort of kind of, basic data work, right? You want to get to the analysis and, having these filters well understood and sort of what's inside that data is probably 90 to 95% of the battle, right? I can tell you right now, here at the Atlanta Fed, we do academic seminars constantly. Every week, we have at least 3 or 4 academic seminars where we have people from outside of the Fed come in and give presentations on their work, and right, like where invariably discussions just sort of get ground to a halt is around what is your sample, where did the data come from, are you looking at this the right way, right? And occasionally we'll have some experts in the audience that'll be able to take people to task on this. But yeah, like this is kind of what we do. This is the meat and potatoes. This is also where I've probably had the biggest career setbacks in my professional career. Early as an analyst, going through and doing some incomplete filterings have absolutely wrecked my day. And so, the more discipline you can have on that, the better you're going to look in front of your direct reports and or your higher ups, and the less mea culpas you're going to have to issue later on down the line. So with that, let's see now. Where do I want to take this conversation? Let's go ahead. Okay. Okay, here we go. All right. Let's go ahead and just do a breakout exercise all together. I don't think we need to necessarily do this individually, so we'll just go through this all at once. Give me one moment here. Open this up too as well. Make sure I'm on the right page. Look at that. Look at that. Look at that. Look at that. Good. Filters. We got filters. You got missing variables. All right. Okay. So, I think yesterday we were looking at winter flights. We were looking at delays. We were looking at here. Let's go ahead and do one where let's do it. I did that. Okay, good. Let's go and look here. Let's see. I want one flights operated by United, American, or Delta. So for United, the airline code is UA. For American, it's AA. And if you've flown Delta out of Atlanta, you know that their airline code is DL. All right. So my main data set is flights. So what am I going to do? You tell me what to type, guys.
Filter.
I'm going to filter.
Um,
Which column?
Carrier.
Very good. Carrier. And what am I going to do?
Um, how do you list them? You just go straight into listing
Yep.
UA and A.
You can do C here as a
Oh,
list.
C.
So, but what type of am I going to do equals? Am I going to do in? Am I going to do what am I going to do?
N.
Very good. The percent in, and then am I going to type UA or am I going to type something else?
Like asterisks or something around it.
Quotes, yes,
Oh,
UA.
quotation marks.
Yep. I like using the single quote only because it saves me having to hit shift. I know that's like seems real petty and lazy, and I fully admit that it is, but that's just me. So I use the single quote. You can use double quote. They're both equivalent. There's one case where it kind of does matter, and it's like a trivial case, so don't even worry about it. You can use either interchangeably. UA, A, and DL. And what does that get me? That gets me a whole lot of nothing. Why is it getting me? Filter carrier. Oh, I forgot to close this up. That's why. And if you ever have a situation here at the bottom where you see this little plus sign in your console, that means you've run your code, but you haven't completed it yet. And R is still waiting for you to finish it out. So it usually means you've forgotten to close the function, or you've got like a pipe here, but nothing underneath it, right? If you need to get rid of this down below, you can do Control C. Or, I'm sorry, just hit escape. Just hit escape. Okay, so if I run that, I should get UA, AA, DL, blah, 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 right? So I can see in this carrier over here, right? I've got a bunch of UAs and DLs and AAs. What's my next question I want to ask? So number two, flights operated and then delayed by at least an hour, but made up over 30-minute in flights. Okay, so this is a little bit more complicated, all right? So delayed by at least an hour. So the departure delay was at least an hour, but it made up over 30 minutes while in flight. So let's go over to here. Let's take a look. Let's just take a look at our filter data. All right. So here we have our first filter, right? So I only got DLs and AAs and UAs, right? So the filter one is that it was delayed at least an hour, right? So what numbers need to be in departure delay?
Mm, one.
So departure delay is in minutes, right?
The
Oh,
negatives?
Well, I want to get well, I don't want negatives because that means that they left early. So it needs to be a positive number, right? So if it's in minutes, make sure that's
it's like
right.
60 minutes.
That's right. That's right. So and it says by at least an hour. So is that greater than or equal to?
Um, Greater than or equal to.
Bingo. Greater than or equal to 60, right? So on greater than or equal to 60, right? Let's go ahead and view that. Right. So departure delay is at least an hour, right? And we got some pretty big numbers in here, don't we? Got 2 hour delay here, right? I've got this one. This is what, like a 7 hour delay, almost 8 hour delay. Was that right? No. 360, so 60, yeah, it's over 6 hour delay here. All right. But made up at least where's my arrival delay? But made up at least 30 minutes in the air, right? So the difference between this number and this number should be what?
30.
30 or more, right? So if I just take this number and I subtract this number, right? I only want those flights where the arrival delay, right? The scheduled arrival delay um, is 30 minutes or more or let me say this the right way. The difference between this number and this number is at least 30. Does that make sense? So if it's positive, that means that this flight not only left late, but it arrived even later, right? If it's equal, that just means that it left late and it just arrived late. That's fine. If this number is smaller than this number, that means that while it it departed late, it was able to make up some of that time in the air, right? So you can kind of think about it in terms of like, when that flight is scheduled to take off and scheduled to land, someone's hitting stopwatches at both airports and is tracking to see when that flight left and when that flight arrived. And so in theory, if it had the exact flight time that it was scheduled to have, right, those two clocks would be the same, right? So, but if it isn't, then it means it made up some of that time in the air. So departure delay. So, right? But made up over 30 minutes in flight. And so what we can do is I can do dep delay minus let me see. Let's go back into my data here. Is it arrival delay? ARR delay is at least 30 minutes. Right? What do you guys think? Right? So I'm kind of doing it all in one operation here. I can also break this up. I do this often. I do this frequently. Not because like I not because I move my lips when I try to read silently, but because these things get really complicated, and I want to see exactly sort of what's happening on the back end. And so what I often do is I'll add a mutate, and I'll do delay diff, right? Something like this, and I'll just do dep delay minus arrival delay, right? And I'll just do, let's say delay diff is greater than or equal to 30. Do you see what we did here? Right? So we kind of talk through this calculation that we want to do, right? I want to look at the difference in the delays between departure and arrival. And if that difference between those two is greater than or equal to 30, that's what I want part of my selection. Let's go ahead and let's just, I'm going to filter that out real quick. Let's just go ahead and see what that actually does, right? So we got all my stuff here. At the very end, I've got this delay diff variable now, right? And that's okay.
Mine
I can
haven't
add,
been,
I'm sorry?
sorry, mine haven't been popping up. Even I'm not even able to see flights.
Now I'm able to see flights? Oh, no.
No.
Well, I'm glad you brought that to my attention. Let's go ahead and share your screen. Let's see what we got. Okay, well, you got flights there. That looks good. Go to week 2. Flights, filter, carrier. Good, 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 good. That looks solid. Can you uh can you put your cursor on line 89? And I think you're on a Mac, is that right? Do Command Enter and just run that. It may take a second. It is taking a second. There we go. Come on. Session memory limit. No kidding. That's why. See, okay. Okay, there you go. Once you scroll over, it'll be no. Keep staying there in your serial data window. Yep. There you go. Yep. Scroll over. There you go.
Okay.
Keep going. It's gonna be down the very end. Down the very end. Bingo, bango. Awesome. Awesome. And you're hitting a session memory limit. That's pretty wild. So you see a little area on the bottom? There's a little yellow
Mhm.
banner down there. I
Yes.
can't. Okay, that's sort of your little notice that like the resources that we kind of give you initially are kind of at their maximum. I have the ability to go in and adjust that for you.
Mhm.
So if you ever see that while you guys are working on homeworks or assignments or whatever, um, go ahead and send me a message saying, "Hey, like I'm running low on I'm seeing this message at the bottom of my screen." You can just screen cap it for me if you want to,
Mhm.
and I can go ahead and adjust those limits.
Okay, yeah,
I had
because I see
also
it a lot.
seen that.
I'm sorry.
Oh, I'm so sorry. I
Yeah, go
said
ahead.
I
No,
had also seen that on the first example that we were given, and so I had
Gotcha.
to start with a new one
Yep.
because I guess I made like a lot of mistakes. But that's
Gotcha.
good to
No,
know.
it's not even mistakes. You're when you're dealing with some of these larger data sets, like they can kind of blow up inside of R pretty quickly. And so it's not just so if you can see on mine, like I've got, I'm pretty close to that limit as well. Like I think, yeah, you got 857, I got 779. And so these things get pretty large pretty quickly. And so if you're ever running into a problem with that, just say, hey, I'm running low on memory or I'm running low on I'm getting this little message down the bottom. Um,
okay.
yeah, but I think you shouldn't, I think we're going to be, yeah, we should be okay here for right now. Um,
And then I
and
had a
actually,
question.
go ahead, please. Yes.
Sorry. Also, the first flights,
Mhm.
it wasn't up either.
Weird. I think it may have something to do with the session memory limit.
Okay.
And so after class, what I'll do is I'll go ahead and increase everyone's limits, and you should be able to go back in and take a look at that.
Okay. Thank you.
So if I do that now, you got to like close out and stuff, and it gets to be a little bit of a challenge. But I think we're kind of nearing sort of the end of today's. We'll probably end a little bit early today. Yeah, there you go. You're getting some errors there. Yeah, yeah, we'll get that cleaned up. Um, this is hilarious. All right, let's go ahead and clean this up right now. Let me go ahead and take a quick detour here. I apologize. Let me go into, let's see, how do I do this? Go into my resources. Uh, you are in, let me see, I'm going to back out here. Ba, 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 ba. Let me look. You are in, you're in working, is notes the one that you're working in?
Yes.
Okay, let me go into settings here. Info, access. Yeah. Let me go into yours real quick. Change your settings, resources. Yeah, let's go ahead and up it to 3. Apply changes. Shut down, restart the project. Okie doke. That's fine. It'll probably kick you out if you haven't already been kicked out. There we go. And you are all set. All right. So you've got some updated resources. Let me go ahead and go back out here. And then you are. Malia, which project are you working in? You're having the same issue?
I was ha- I was having the same issue on the first one that we did, not this one.
Okay, so you're not having that issue now, but you were having it earlier?
Yeah.
Okay. Okay. Yeah, when you get back into it and if you're in there and having issues, just let me know and I'll go ahead and increase those resources for you. All right,
Thank
cool. Let's
you.
go back in here. Where am I? Back in. Actually, it's a good time for me to check my resources. Let me go up mine to 3, get that. Very good. Changes. There we go. Come back on up. And run. Come on, dude. There we go. All right. We are back. We are back. All right. Fantastic. Okay. Here we go. Where are we? We were doing some filtering. Yep. So yeah, we added a column. Where did I do it in? Did I do it here? Nope, didn't mutate here. Yep. Is that right? Yep. Set on the end. So I got delay diff. And I want my delay diff to be greater than or equal to 30. Is really what I want to see. And so if I do this, then I should have, only those observations, right? So we go back to this. So I start with my flights data set, and I filter that I only want these 3 carriers, United, American, and Delta. I create a new variable called delay diff, right? And that calculated the difference between the arrival delay and the departure delay. And I want to keep only those observations where the departure delay was at least an hour, and where the difference in the departure delay and arrival delay was greater than 30 minutes. And if I do that, I should get something that looks like this. So my scheduled departure, my departure delay here, these are all greater than 30, right? And if I look at my scheduled, let's go look at the departure delay and arrival delay, right? So it departed 285 minutes late, but it arrived 240 minutes, 246 minutes late, right? So the difference between those two, I'm just going to call it roughly 40, right? So even though it left, what is that? Almost 5 hours late, it was able to make up about 40 minutes in the air, right? So it didn't arrive as late as it left, but it still, right? But it was at least, it made up at least 30 minutes in the air. So it's something. So same thing here, right? This one left 99 minutes late, but it arrived from its scheduled arrival time only 66 minutes late. Right? So it made up that 30 minutes or roughly 33 minutes in the air. So this is kind of what we want to see. So these are all situations where even though it left late, it was able to make up at least 30 minutes, 30 minutes in the air. Let's go back here. And then for 3, let's go 3. And I want to say, if I, and missing what might these flights represent. Right. So say made up late depth. Right. So if I'm doing some analysis on carriers, right, and who is able to make up their time up in the air, right? How might I break this down by carrier? If I wanted to have a report of individual of individual carriers that were able to do this, what might I want to look at? What might I want to use to do that? Do you guys remember what that function was? Use a group by. Right? Group by allows us to group data according to common factors and perform some analysis only on that group level. So I can do group by carrier, right? And then I can do, let's say, a summarize, right? And so flights equals n, and then average depth delay is equal to mean depth delay, and then I can do average delay equals mean delay, and then average makeup equals mean. I'm going to do, what do we call this? Diff delay diff, right? And this is going to give me a nice little report of the, so made up late depth. So I assigned this to a new object called made up late depth. So made up late departure. If I look at that, this shows me the number of flights that were at least an hour late leaving. What was their average departure delay? What was their average arrival delay? And what was the average makeup in the air, right? So if I take a look at this, so it looks like United was the big one here that had the most number of flights. So actually, almost both of American and Delta combined, right? The average departure delay they're all roughly around the same, right? So call this, I don't know what's right around 2 hours, a little more than 2 hours for an average departure delay. And they were all able to make this up in the air by about almost 40 minutes, right? So this is a neat little way to generate a report by carrier showing these statistics. So if you guys, I'm sure are well traveled. Why might United have such a massive number relative to American and Delta? Knowing what you know about airlines. Sorry, I'm sorry?
Oh, is it because it could be more inexpensive?
It could be. It could be. But what do you know about Atlanta, about Hartsfield and Delta?
That they are hubs in Atlanta?
They're hubs. So Delta flies a ton out of Atlanta, right? So United might use one of these airports in this area as their hub, and so they just happen to have a lot of traffic. It's not that United is necessarily a worse airline than, let's say, United or sorry, American and Delta. It's just that they happen to have the most volume coming out of there. Like New York is not a hub for American and Delta, right? I think for American, it's is it Dallas? I think is their hub, or maybe Charlotte. And Delta is Atlanta, obviously. But for United, it could be that's just that's their home airport, and so they're showing just a greater number here, right? So something to keep in mind, right? As you're looking at your data, right? Like you may think like, God, United sucks. Like, what's going on? Like, no, they're in fact, like their average departure delay was 10 to 20 minutes less than American and Delta, right? When we're talking about excessive delays. It's just that they happen to fly a lot more volume out of there. And so if you think about, what might cause a delay, like what do you think, the most common reason for a delay out of an airport is probably weather, right? It's probably going to be weather. And so if United is flying more flights out of those 3 airports than the other 2 combined, they're going to be the most affected by these weather delays. Cool. And then let's go ahead and take a look at these NAs, right? So when you're doing your data, whenever you have a project and you're making exclusions in your data, What I like to do is rather than just make the exclusion, I like to assign those excluded rows in their own data set, right? Memorialize those data sets, right? So in theory, if you think about it like a puzzle, right? I've got my original data, I got some piece that I'm keeping and some piece that I'm excluding. And in theory, if someone were to come to me and say, "Hey, I don't think you did this the right way. I think you've made a very big mistake and you're excluding way more data than you think you are," right? In theory, I should very easily be able to say, nope, I can take the data that I excluded, I can take the data that I kept, I can mush them together, right? I can append the rows of those two data, and I should be able to recreate my original data set. Does that make sense? It's kind of like a form of, if you ever take like an accounting class and you're doing an audit, right? Assets equals liabilities plus shareholder equity, right? Like the simple accounting identity. If you're, have you guys taken accounting yet? All right. 1 + 1 = 2. Let's just go with that, right? It's a simple mathematical property, right? Like it's the number, the math's got a math, right? And so if I have 300,000 rows of data and I exclude 100,000 rows of data from my analysis, right? If someone at the end of my project says, "Well, walk me back to your original data," you should just very be able to easily just sort of mush all this back together and get back to your original data set. Why is that important? It's a form of audit control, right? It's just a way for you to be able to say, look, I've done my job as an analyst. I've done it very, very well. I've been very thoughtful and methodical and careful with my analysis, and not only in the data that I've kept, but also the data that I've excluded. And I can account for all the different decisions that I've made in my data set, right? More importantly, um, you get far enough into a project and you're starting to answer, questions, and you're going down rabbit holes, which, as you've seen over the last, let's call it, week and 2 lectures, listening to me drone on about this stuff, it's really easy to go down a rabbit hole, right? Right? We just let the questions sort of dictate where we want to go with our work. um, as we start chopping things off, there may be important pieces of information in that data that we actually want to keep, right? There may be something of value in there, like, yeah, I mean, it didn't really help with this question in particular, but there's other data in there that we may want to look at. So let's go ahead and do let's say departure time, dep, delay, NA, right? And I want to keep values where it can do is NA and dep, say dep time NA, dep time, dep time. And what is that called? Oop, let's kill this. And dep time. All right, dep time, dep time. All right. So I am trimming from my data, I am excluding, or I'm sorry, I want a data set that is only those observations where there's an NA in this dep time column. Okay. So I'm going to use is.na. What could I also use? I could also use filter. I could do dep time equal NA, right? These are both the same, right? You can do either one, whichever one you feel comfortable with. I'm old school. I do the is NA. A little more new school. You can use equals NA. And if I run that, I get a new object called dep time NA. And it's got 8,255 observations. And it's got 19 variables. Let's go ahead and open that. So I've got dep time all in here, right? And so the question is, right, what other variables are missing from here? So dep time is missing. What else do you guys see is missing?
Depth delay, arrival
Yep,
time,
yep,
arrival delay,
yep.
air
Looks like
time.
airtime is there, right? right? So, and also there's a couple here where we've got some NAs in the tail number, but that's like not so much important. Really the big thing, right? So depth delay, obviously, right? Because depth delay is just departure time minus the scheduled departure time, right? So that's just a simple math operation. If that's NA, then you know this is going to be NA, but also the arrival time, right? And so what this tells us is that these were most likely canceled flights, right? Not only do they not have any data for them taking off, but they all just never arrived, right? What are some reasons why a flight never took off? I can think of two.
Weather.
Weather, right? Yep. So it had some sort of weather delay, maybe a mechanical delay could be another reason, right? What's another reason why a flight never took off from it? Let's say we're looking at what's this airport code? Give me this airport code. Yada 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 yada. Okay, LaGuardia, right? LaGuardia. Why? Okay, what's another reason other than weather that a flight never took off from LaGuardia?
Not enough staff.
Yeah, think more generally. In order for a flight to take off from an airport, what do you need to have?
Gas, oil.
Got to have an airplane.
That-
Got to have an airplane, don't you? Right. So maybe the flight never arrived there, right? Maybe you got held up at another airport. And if we notice here, right, these are all assigned to specific tail numbers, right? Right. So I got specific tail numbers for the most part assigned in these flights. So it on-time data, all flights that departed in 2013. Well, obviously not all flights that departed because I got a bunch of NAs where they never departed. So that's not true. Okay. So, but I do have scheduled departure times. I've got flight numbers, right? So, rather than just being flights that departed, right? So clearly not all the data in here departed. What we might be looking at is an itinerary, right? Like a docket of flights, right? So every day the airline probably files a flight schedule, like with air traffic control, and says, okay, I've got these flights that I need to leave from this airport, right? And they need to leave at this time because they need to arrive at the other destination airport at that time. These are all are filed flight plans, right? So that way I know what's supposed to be in the air and what's not, right? So air traffic control isn't freaked out when a bunch of airplanes from New York start just careening towards LA. And right now you got to figure out how to manage that airspace, right? So they schedule these things in advance. What we might be looking at is what are filed flight plans by the airlines, right? So what might happen is, let's say the day before, they may file a flight plan with air traffic control. And what we're seeing now is whether or not those flights actually took, whether or not they took off. If they took off, did they leave early? Did they leave late? And then their scheduled arrival destination. Did they arrive on time or did they arrive late? And so that could be another reason why. So it could be, yeah, it's a weather delay, and so the flight just got canceled, or it could be just simply the plane was not there. And that's kind of something to think about. So these are all little nuances with the data that could be in here. And that's also another thing too. Like when you're going through projects and you're going through work, right? Like, okay, description: on-time data for all flights departed New York City in 2013, right? That's a pretty compact statement. That's a pretty definitive statement, right? These weren't on time. These weren't even close to being on time. They didn't even show up. They didn't even leave, right? So there's a layer of nuance in this data that, as we're communicating it to our audience, again, one, like we have a better understanding what's happening with the data. We can ask better questions. But then also, um, we build that reputation with our audience to say, well, no, in fact, this data is, a little bit more nuanced than that. More crucially, for you guys specifically at a personal level, when someone tells you something and is based off of data, you can now say, well, hold on a second here. That's not exactly right. Right. So, what are we talking about in economics now, top of mind? We're talking about employment, right? Especially for you guys, right? As college people who are in college, the conversation is not exactly the most supportive right now, is it? Right? Because all you're hearing about is a bunch of college grads can't find work, right? But what's the unemployment? Is the unemployment rate through the roof? Actually, no, it's not. Unemployment rate is pretty low, right? It's in the fours, right? 4% unemployment rates is historically very low, and if we think about it in terms of economic theory, is a very 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 low number. So how do I square those two across, right? Like if all these college graduates are having just a hard time looking for work and they can't find work, but the unemployment rate's also low, like these two seem kind of at odds with each other, don't they? Right? Right? Is anybody lying to you? No, not really. But the way that we square it is, well, what does it mean to be unemployed? Right? In order for you to be unemployed, you have to be what? Actively looking for work. Right? And if you're a college graduate and you're still in school and you are, um, let's say, discouraged from looking for you've made a good faith attempt to look for a job and the market is just garbage and you can't find anything. Maybe you go to graduate school instead, right? Are you included in the unemployment rate? No, you're not looking for work. Let's say you say, you know what, I'm going to take a gap year, right? Maybe I'll travel a little bit, go see the world, get some experience, right? Um, are you included in the statistic? No, you're not. You're not looking for work. Maybe you say, you know what, I'm just going to go move to some other city where I think there might be some opportunity. I'll take a part-time job working at a coffee shop or, working in a restaurant or doing delivery, something just to kind of make ends meet, right? But on the side, try to get into my career, whether it's economics or whether it is finance or banking or accounting or whatever. Kind of just bide my time until the market is a little bit better shape. Am I included in the statistics? No, I'm not. I'm not looking. In fact, I don't. If I'm working, as a barista, something like I'm not part of the labor force, right? I'm one of the employed, right? I may not be working the job I want to be working. I may be underemployed, right? And that is something that we do track. But the data isn't as clear cut always, right? As it may as it may seem, and that's why I spend a disproportionate amount of my personal time getting in fights online with people, going through data and looking at exactly okay, you said something and that doesn't pass the smell test because my lived experience says, okay, you're completely wrong. Um, there must be something in the data and going through and pulling the data, seeing what they're looking at and trying to pinpoint exactly, okay, so how are you basing this claim and why are you just empirically, philosophically, and demonstrably wrong? Because it's not that people lie all the time with data, and if you get one thing out of this class, by God, I just hope you just get some smell test you can run on yourselves, right? To say like that doesn't that I'm not that the math ain't math in here, right? Like 1 + 1 does not equal 2. Um, anyways, tangent aside. What other data is in here? So we asked, so flights missed, what other variables are missing? We talked about those. What might these flights represent? We talked about that. What data do we actually have though, right? So I've got year, month, and day, right? So that's kind of crucial. Um, and I've got some tail number information. I've got the airline information here, right? Um, and I've got the time and the hour as well. And so if you recall, we had some additional data sets in here like weather, right? So we can merge in like weather information to see if weather was a critical factor with these. Right, we've got some destination airports as well, so we can kind of pinpoint into what's going on with these flights, right? Was it a weather delay? Did they just not show up? Was the plane running into some sort of a mechanical issue? Things of that nature. Are these actual like major airline? Like who's MQ? I have no idea who MQ is, right? 9E, like what carrier is 9E? I have no idea, right? Are these major carriers that were running into issues, or are these smaller carriers that are running into issues, right? So maybe they're just, you know, maybe they filed a flight plan and it's a private charter, right? And or it's a private pilot, and they decide they're just not going to fly that day. That could be the issue. Does that make sense, guys? Cool, cool, cool. Let's do one last thing. Let's go back to this made up late data. I want to go ahead and run what's made up late look like. I want to get you one last thing. Okay, so I've got some stuff here. I've got AADLUA. How is this table being sorted currently right now? It's alphabetical by what? By carrier, right? So American Airlines shows up first, Delta shows up second, and United shows up third. But what if I want this to be sorted in order of the average makeup, right? So one way I could do that is by taking all of this, and I can pipe it into arrange, and I can do average makeup. If I do that, right, now I go from least to greatest in terms of the average makeup, right? So now I've sorted my final output in order of the average makeup, right? So arrange always goes from least to greatest, or smallest to largest. And if I want that to go in the opposite direction, I can just use desc for descending and wrap that around my variable. And that should do the exact opposite. Now going from greatest to least. Does that make sense? Did I blow you guys' minds there in the last second? A little bit? A little bit? That's okay. The important thing is that the arrange allows us to sort our output according to the values in a specific output column, right? So if I have data in my output here, I can sort it by any number one of these. I can sort it by carrier, number of flights, average delay, average departure, arrival, or makeup. Right? I can do that for any data object, not just our output here. I can arrange that data anywhere in here. Anywhere I've got data, anywhere I've got columns rows of data that's arranged in columns, I can do a sort on there. And that is it. That's all I got for you guys today. I'll post this YouTube video out here shortly as soon as it is done saving out to my hard drive, and I will take a look at what else we all have to do and come up with a game plan for tomorrow. Do you guys have any questions for me before we go? No? Good. Cool. Awesome. All right, guys. Well, I appreciate you coming today, and I will see you tomorrow morning.
Thank you.
Awesome.